right, ladies and gentlemen, take a look here. So we're going to take roll. What you guys have here, I do have some people. I'll explain details as we go along, but let's just first take roll, see who's here, who's not. Okay. See if I can do this here. We got Susan Abdullah. Susan here. Okay, Christopher Bay. All right. Fernando Barrios. Got Fernando Barrios. Adrian Bautista. Adrian Bautista. Ralph Castillo. If they miss the first day, we get to what? It's another thing you guys want to learn. If they miss the first day, what do we do? Get rid of them. Drop them. Drop them. Like an old bad habit. They get dropped. Yes. Who? Oh, hey, Fernando. Okay. See? Told you. You guys want to register for YouTube. How you doing, Fernando? Thank you. Thank you for letting me know as well, because I'm blind, believe it or not. And this is way too much for me. I'm already overwhelmed looking at all these things. Anything else? Anybody else? We got everybody covered here? All right, good. I want to go back and double check. Okay. So you guys have no more questions on the syllabus. Is that right? All right. I got to ask you. You guys got to start taking these notes here. Here's going to be a big question here I'm going to ask of you guys. Mr. Judge is going to take some demographics questions here. I want to know how many children do you have? Yeah, I know those. You don't like those questions? How many children do you have? You know, those pesky little that are always crying and complaining. What happened here? How many children do you have? Let's find out. Okay, we're going to start over here. How many? One. Jeez. I think I need an extra. Whatever that is. Okay. How many children? How many children? I hate to point, but there's a reason. How many children?
Zero as far as I know.
Mm-hmm. I think these days you'd probably know. They'll find you. It used to be you got away with that stuff. Tricky question. Okay.
Well, my mom passed away when I was 18, and I'm the oldest, so I have to help my dad raise my siblings.
Yeah, but how many children do you have? Okay. I know it may feel like your siblings are your kids. Trust me, I'm the oldest too. 0. Okay, now I'm going to do something that's bad. In fact, everything I'm doing is bad. I'm going to do some bad things. That's bad. Now, what is what I did here? First of all, what did I do? Does anybody know what I really did here? This is called something here. What did I do? I gathered data. Okay, you guys with me on that? I gathered data, but who did I gather data from? There's some details we got to talk about. Okay? If I consider you see this rectangle? I'm going to say this is Mr. Judge's 227 class, okay? You're considered my population. So everybody in the room, you see this dot? You see this here? That represents everybody's information. It's called a data value. So everything that you see here, These are data values. So I gathered data from a population of the room here. You guys are in this room. Every dot is you. Okay, so you guys know it's my population. But I did something here. Anybody notice what I did? I did about 3 things that were bad. What did you guys notice here? Yeah, you can't make up data. That's an obvious one. You can't make up data. People do though. Shh. That's bad. That's horrible. What else did I do? What do you notice? Good. I took, in case you didn't notice, we took what's called a what? A sample here. Okay. We took a sample of data. And I'm going to do something here. I'm going to put a little circle here. This is my sample. A sample is when we ask some people, not everybody. Okay? So we got a population out here of people in this class. I took a sample. Good. What else did you guys notice? I did something about the sample that wasn't so good. Well, we made up data. You can't make up data, but we talked about that. Never make up data. I did it. So sometimes it's how can I put this? People remember what you shouldn't do more than they remember what you should do. So you can't make up data. So that's a bad thing. What else? I took a sample because I didn't ask everybody. Okay? I want to give you a definition, though. Definition of what we call population size. It's related to what we're doing. Population size, we have a letter for it, capital N. That is the number of data values in a population. So here's the definition of a population size. And if we ask everybody, this is AKA, this is also known as taking a census. Okay? So when you ask everybody in a population, that's taking a census, by the way. So I did not take a census, right? Because I didn't ask everybody. I didn't take a census. I only asked some people. I took a sample. Okay. And I'll say here, definition here, we'll do this here. We took a sample. We have something called a sample size, and that's a lowercase n. And that's the number of data values in a sample. Okay? So this is a sample. What's the sample size? Do you guys know? What's lowercase n here for this example? I got to count to get the sample size, don't I? You guys see what I'm saying? So let's count. You guys ready? Is it 24? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 data values. So ladies and gentlemen, good for you. The sample size here is 24. It's the number of data that you gathered in the sample. Okay? All right. Now you say, what would the population size be? Well, it's everybody in the room. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 people in the room. So the population size, big N, is 30. I don't think so. Something's wrong. There has to be more than 30. Maybe not. 24? Do we really ask 24? No, we made some up. That's why. Shh. Don't tell anyone. That's right. It's crazy. Never make up data. Sometimes people do. There's another thing that's wrong with what I did. Anybody notice? What's the other mistake I made the obvious kind of thing. I know I'm giving you definitions. I'm showing you what they are, how they relate to each other. I did something that you don't want to do with samples. Besides making data up, what did I do? This sample is a bad sample. Anybody know why it's bad? Yeah, that's another thing. But in this context, we're okay with that. But what do you think I did? Do you guys notice what I did besides make up the data? What else did I do? Anybody notice? Let's ask you guys another question. Anybody here feel left out when I gathered the data? I only asked data for people who were closest to me. Did you guys notice that? The people in the back, we didn't ask you anything. We ignored you. We only asked the people that was convenient to me because they're closest. So I want to make sure you guys understand something here. This sample that we're talking about was a convenient sample. And I always have to double check how to spell convenient. It's one of those words, convenient. It was a convenient sample. Let me illustrate to you why convenient samples are bad, right? The classic example used in your book, that textbook, that PDF file, the author Trilla says this to people. It says, if a warden of a prison wants to kind of describe how people in California feel about the death penalty, and that warden only asks inmates, because that's where the warden's at, right? It says, hey, how do you feel about the death penalty? What do you think inmates are going to say? Oh, no, that's horrible. No, right? And if that warden now says, hey, I gathered this data, and I want to say it represents the data for the state of California, what's the problem? It's a no-go, is that right? You see what I'm saying? That's a convenient sample. So this is what I did. It was convenient for me. What's the best thing you can do when you take a sample? The best thing you could do, there's something you really always want to do. What's the best? You want it to be random. Yes. However, there's a problem. You want your data to be random. Now, you might say, what's the definition of being random? Well, every data value has an equal chance of being chosen. It's random. That's the formal definition. Back in the day, believe it or not, right? You know the first day here, people show up for a math class, right? Back in the day, I used to have over 100 people trying to add the class. Over 100. And I might have only space for an additional 22. I was in a bigger classroom. Or maybe additional 25. I was in a bigger classroom back then. And so, okay, you only have space for additional 25. I used to have to do a raffle. I'd have people print their name and say, okay, number 1, here's your name. Number 2, here's your name, blah, blah, blah. Then I used to have these numbers, and I put them in a bag, and I kind of have to pull number 21, number 18, number 4. That was random. So I can illustrate to people that people had an equal chance of adding the class that way, because everybody had only one number. We shuffled the numbers around, we closed our eyes, and we pulled randomness. Can't do that anymore. So I used to give that definition. Everybody has an equal chance of being chosen. Now, very often, we can't do a random sample so easily. What's the second best? This is the best. We have the second best. If we can't be random, what can we do? Huh? Well, we could. It's called systemic. We take a systemic sample. Now, let me describe what being systemic is. Being systemic is like when you say every kth person. You ever been to Disneyland? Anybody? We have any Disney freaks here? My daughter's a big old Disney freak. You ever been to Disneyland, and what do you guys notice at Disneyland? Do they ever have anybody trying to gather data? No? Yeah. You know, they're the kind of people with that kind of clipboard and everything. It's not a clipboard. They have like an iPad or something. I don't know what they have. They're walking around and they're ignoring you. And you try to get in front of them and say, hey, ask me a question. Ask me. And they ignore you. They're doing a systemic sample. You say, what do you mean? They decide ahead of time, like they might think, okay, every 50th person that passes me. Or maybe they decide every 30th or every 25th or maybe every 10th. They decide every kth. That's how we describe it. Every kth person, they ask the questions. Now, that is the second best thing you could do if you can't be strictly random. You're systemic. So, you know, back in the day when I had like 125 people trying to add, I could have thought, I'm only going to add every fifth person. So people who had 5, 10, 15, 20, 25, you see what I'm saying? I could have done that. They didn't know when they came in. That's the key. They didn't know, and I could have done that. It would have been the second best way to do things if it wasn't strictly by the definition of being random, meaning everybody has an equal chance. So you'd have to create a system where you have an equal chance. That's the best way to gather data. Okay, the second best would be to be systemic. The worst would be convenient. Although, you know, there are some examples of convenient samples that people use, but in a strict case, you know, by law, you wouldn't be able to get away with it. Right? In a medical setting, you can't get away with these convenient samples. Anybody know what's another example of a convenient sample? They're kind of everywhere. Yeah. Like if you go on Yelp or Best Buy, like you ever go on Yelp, you're trying to figure out a good place to eat. You look at the ratings, the number of stars. Anybody here rate things on Yelp? Anybody here rate anything? You go to Best Buy and you rate something? You buy something on Amazon, you rent a movie on Amazon and you rate it? You guys know what I'm saying? It's everywhere. Well, what's bad about that kind of data gathering?
You only get people that are either really happy or really upset with the product.
Yeah. You only get, what we say is you only get people who have chosen to respond. And they might be strong enough either way. So it's only people who have feelings about responding, and that's not really the whole picture. You know what I'm saying? It's not really the whole picture. And you know, sometimes they used to encourage you to do surveys by enticing you. So it's like people who are enticed to give a survey. You know, Barry Bonds getting into the Hall of Fame was another area online that used to say, hey, 72% of people think Barry Bonds should get into the Hall of Fame. And it always had a little asterisk. Oh, these are people who have chosen to respond. So if you can't force people to if you can't get data randomly, or you can't get data systemically, and if it's done on a volunteer basis, that's really not very scientific either. So you get this data gathered, on a volunteer basis, or enticement. You got a free coupon because you gave a survey. So I just want you guys to know that next time you use Yelp, or next time you're on Amazon, or maybe you see Netflix and it has 4 stars, right? But you want to know the interesting thing? Don't we use those kind of things as guidelines anyway? I know I do. I use them. It's not always guaranteed. I would wonder, hey, how did this place get 5 stars? How did it get 4 stars? I don't see it. Why is this product so loved by everybody? It's not always a guarantee. Sometimes you see why. You go, oh yeah, I see this. Sometimes you say, something's wrong here. Okay, just so you guys know. So whenever they solicit you without it being random or systemic, scientifically, it's not acceptable. You got to throw it out. What do you guys think? Is that pretty easy? Is that pretty simple? Right? How are you guys feeling? Are you feeling okay? You feeling like a break? Because unfortunately, we got to give you breaks too. Feeling like a break? You've been sitting here since, usually my classes start at 8. Somebody made it start at 11. I don't want to say. Do you guys like getting up at 8? No? Are you guys the people that get up later in the day? Really? What time do you get up? Good for you. You know what time I got up? Yes. How'd you know? I was like, what time's my class start? 11? Oh, God. What am I going to do? Huh? Yeah. Horrible. So I was like, okay, well, I actually had to set all this stuff up and make sure it works. And I had to call Texas Instrument TI to get the calculator to work. So big drama. So I'm actually glad I got here earlier, but usually I'd be done by now. Going home for lunch. I get up at 5. That's what old men do. We get up early. Rather get it done early if we can. Early. Young men, they get up late. What's the latest you've gotten up? As a kid. Because I tell this story too to friends and family. I remember my dad getting mad at me because if he found out I got up, this is after I graduated from high school. If he found out I got up right when he got home from work, he was mad. My dad was mad. So some days I'd hear my dad pulling up. I was still in bed. Like, oh, I better get up. My dad would look at me. Did you just get up? No. I've been up for a while. He knew. He knew I was lying. Did your parents get mad at you for sleeping in too much? No, that was my dad. My dad. Yeah, and then my daughter sometimes she would sleep and go, what time's Ashley getting up? Jeez. What time do you go to bed? And she goes, well, I was studying. Okay, well then that's fine. For me, as you guys knew, I didn't study until after I got out of high school. That's when I started studying. But those late hours, it's interesting. Some kids are still asleep. They won't get up to 3 or 4. Okay, so you guys know about gathering data. You know about the sample size. And you know what you're going to do now? I'm going to do this. We're going to organize our data. Okay, I'm going to show you guys how to organize the data before I give you a break. There's 2 types of organization of data that we're going to talk about here. Number 1, a frequency table. Number 2, a relative frequency table. So, okay, yeah, you gather data, but you want to organize it too, because you want to look at it, you want to make some sense of it, right? So when I say a frequency table, a relative frequency table, I got to give you another definition. Definition of the word we call frequency. And that's the frequency of a data value. And we denote it with a scripted F. That means frequency. That's the symbol for frequency. Okay? And that is the popularity of the data value. It's how popular the data value is. And I'll just say how often, how frequent it shows up. We call that a frequency, how frequent it shows up, right? So let me organize this data for you. Let me go back and say, okay, I'm going to do this. This is what you guys want to do. I'll put like the word data value, and sometimes I just put the letter X, okay? And then you're going to list the data values from smallest to largest, okay? So what was the smallest data value that we gathered? 0, good. And then we have a what? A 1, a 2, and the largest is a 3. Is that true? So we're organizing our data from small to large. So I'm going to create a data column, then I'm going to create a frequency column. What do you think that is? How many times it shows up? Good. So I got to go to the 0 and we got to count again. You guys see what I'm saying? I'm going to have to erase all this. I'm going to count how often a 0 showed up, how frequent my zeros were. And let's do that. Let's count all the zeros. Let's see if we can find, this is called the frequency of the data value 0. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What do you guys get? The 15, there's 15 zeros. That's how frequent my 0 is. You guys okay with that? You guys see what I'm saying? Yes. No, this is just a frequency table. We're gonna show you. You have to learn a frequency before relative frequency. So we're saying there's 15 what? Zeros. That means, you guys know what that means? That means 15 students said they had no children, 0 children. Okay. How many students said they had 1? Let's get the frequency for the number 1 now. I'm going to change the color. 1, 2, 3, 4, 5. 5 students said they had 1 child. That's the frequency of the data value number 1. 5. Okay, so I'm going to just share with you guys that was 15. Frequency of 1 is 5. How many students said they had 2 children? Let's count. 1, 2. Okay, 2 students. So we're going to say what now? 2. 2 students said they had 2 children. How many students said they had 3? Let's go. Let's find it. How many students said they had 3 children? Let's find out. 1, 2, 2. So the frequency of the data value 3 is also what? 2. There you go. What do you guys think? Isn't that pretty simple? It's about counting. Knowing the definition and counting here, you found the frequencies of every data value, and this was organized in a table. This is called a frequency what? Table. Okay, you guys okay with that? Yeah. You might say to me, okay, that's fine, but what's a relative frequency table? I'm going to give you the definition here. Definition. Relative frequency. I abbreviated RF. It's a formula. It's defined to be the relative frequency is going to be the frequency over the what? Sample size. This is the relative frequency. Frequency over the what? Sample size. Yeah, and then I want to share with you guys another formula. Let me give you another formula. There's another fact here. You guys want to take down these notes here. You know the sample size is. You know what you can do? You see, anybody know what the symbol is? It's a Greek letter. Capital sigma. This is the Greek letter sigma. Okay, you might want to put a little these lines there. What does that symbolize in the statistics course? You guys know what sigma really means? It means to sum. What is summing? Adding. Do you guys know you can get the sample size by adding the frequencies? You say, what do you mean? You see this here? What I can do is add all my frequency values right? Add these numbers here. I'm going to put a little arrow. What is 15 plus 5 plus 2 plus 2? That's 24. Didn't we say the sample size was what? 24, ladies and gentlemen? That's going to be an important formula to know. That when you add the frequencies, you get the sample size. Because what if they gave you this information? What if they just gave you a table and they want you to create a relative frequency table and you say, well, how do I do that? Well, you use the definition. What's in the definition? The sample size. So I want you guys to know the sample size is the sum of the frequencies. And why do you care? Because you can now find the relative frequency. What do you mean? Let me share with you guys this. If you want to now say, how do I go from a frequency table to a relative frequency table? It's very simple. You just do what? 15 over 24. 5 over 24. 2 over 24. 2 over 24. So if you notice, I'm going to even put the colors here. 15. 5. 2. 2. Divide by the sample size of 24. Now you are at a very important place here, ladies and gentlemen. Very important. I recommend you always bring your calculator with you. Do you guys know why? Because relative frequencies, this fraction, we use actually the decimal representation. So they're going to tell you, or at least I'm going to tell you, approximate your relative frequency maybe to the nearest what? Thousandths position. Do you guys know what that means? Thousandths? Yeah, let's talk about this. Okay, because this is going to be a very big part of our class. Approximating these fractions. We need thousandths. Let me go back to place value. Let's see if you guys know. This is the S portion of the course. You go, what's the S portion, Mr. Judge, when we talk about this supplementary portion? Here's your decimal. To the right, that first position, these are, I'm going to put a box, put another box, put another box, and another box, and another box. To the right of that decimal, what's that first position? What's the name of it? The ones are actually to the left here. Yeah, here's the ones. This is called the tens position. THS. By the way, this is the tens position. So it's kind of weird in the way the first decimal place is called the tenths position. It has the abbreviation of what? THS. And then what's this next one? Hundredths position. Another THS. And then the what? Thousandths. The abbreviation THS. And what comes after thousands? 100,000ths. And after the 100,000ths, what do you think we get? The million THS, just so you guys know. So we're really dealing with numbers that are to the right of our decimal. And just to kind of give you a complete information, just to be complete. Ones, tens, what's the next one? To the left, it's hundredths. And then thousands, just to kind of compare and contrast. But I want you guys to really see the real difference. It's in how the word ends. ones, tens, hundreds, thousands, 10,000s, 100,000s, millions as you keep going. But the other direction, it's THS. So what we're going to focus on in this class is the information that's where? That's over here. Can't really. It's weird. Anyway, I think I need new tips. They're at home. See the THS? So if they say approximate to the thousandths, how do you do that? Do you guys know? Let's look at the number. So we're going to have to do this. Where's our TI calculator? There we are. 15 divided by what? 24. Oh, that's already. What is this? That's not even approximate. That's equal. Let's write down the number. 0.62 what? 5. You guys see that there? So let's think about this. This is like, okay, tenths, hundredths, thousandths. How you would really do this is you look at the digit to the right. There's no digit there. Well, you can put a 0 if you wanted, but you don't need to. So this is equal to 0.625. Okay, you guys okay with that? And now let's do 5 over 24. 5 divided by 24. What does that give you? What's this? Can you guys see it? Okay, how's that? Is that better? I just want to share with you guys how to use that calculator. Did you guys see why it's probably a good idea to get this version if you can? I mean, if you went out and you bought, maybe you already have it. Oh, here's another thing you could do. Go, if you wanted to get that physical copy of the TI 84 Plus CE, what's that app again? What do I use? OfferUp. Some of my students have gotten this calculator on OfferUp really inexpensively. Say, Mr. Judge, I found it for $30. It's like, really? That's great. I found it for $25 on OfferUp. You can find it on OfferUp. You can go in Best Buy and buy it. How expensive is it on Best Buy? Go to Amazon. It's another place. Ooh. It's $160? It can't be. It's horrible. I hope not. It's like $125. I got mine. I got a purple one. Did I get a purple one? I got to check. Because sometimes students on a test, they go, oh, Mr. Judge, I forgot my calculator. So I have an extra. I only have one, though. So I had to buy it, too. You see this? Guess what I have to do? I have to buy that one. This one, too. It's the same price. Horrible. Anyway. What's this digit? Let's write it down. This is 0.208 with a bunch of 3s. Is that true? Let's see if we can figure this out. Where's the thousands position? Tenths, hundredths, thousand. Look at the digit to the right. What do you guys know about that digit? If it's a 0, 1, 2, 3, or 4, put your eyeball here. If that digit to the right of the place value that they indicate, thousands, 3 decimal places. If that digit is a 0, it's not. If it's a 1, it's not. If it's a 2, it's not. If it's a 3 or 4, it's a 3. Do you guys remember what you do? You actually just erase this. You erase the digits. Where's my eraser? Say gone. The number is approximately 0.208. Okay? You just chop off the digits. What if the digit was a 5, 6, 7, 8, or 9? What do you guys do? You add 1 to the 8, make it a 9. So remember, if it's a 5, 6, 7, 8, or 9, you add 1. If it's a 0, 1, 2, 3, or 4, you ignore it. Only 2 things. So you're going to have to go through the calculator. And what's the next one? 2 out of 24? Okay. 2 divided by 24. What does that give you? What is this to the nearest what? Thousandths. 0.083. What's the digit to the right here? If you guys want to see that again, let's see that here. Zero, 8, 3 with more 3s. What's this going to be? 10, 100,000. Look at the digit to the right. It's a what? 3. So what does that mean I do with that digit? Since it's a 3, what do I do? Get rid of it. What if that digit here was like a 7? Add 1 to the 3 and it'll be 0.084. Okay, just to let you guys know. Remember, 5, 6, 7, 8, or 9, add 1. If it's a 0, 1, 2, 3, or 4, just delete it. So 0.083. Now, the nice thing about this is if that's the same fraction, it's the same approximation. Is that right? 0.083. Now, this is 0.208. What are you guys looking at here now? What is this whole thing now called? Right? What do you think the name of this is going to be now? It's a relative frequency table. Yep. So if you're going to create a relative frequency table, you need a frequency table. And then why do you care about relative frequency anyway? Give you another quick fact. Yep. Every decimal can be written as a percent. So I'm going to write this down. Every decimal, and that's what you're looking at is decimals. Every decimal can be written as a percent. How do you do that? Do you guys know? Yeah, we're going to take that. In other words, if we take a percent, you just have to multiply it by 100. So every decimal that you see in your life, if you multiply it by 100, that's a percent. And that just moves the decimal how? That moves the decimal 2 spaces to the right. Okay? So that just moves that decimal 2 spaces to the right if you multiply by 100. So even though this is a relative frequency table, I want to start thinking about these decimals as a percent. And we'll see, in other words, this is going to be 62.5%, 20.8%, 8.3%, and 8.3%. We're going to see why we care about this, okay? But we're going to take a break. Whew. We'll take a break. How many minutes of a break should we take? Anybody going to go get some coffee? Good for you. Anybody going to go get a snack? Should we take a 15-minute break? 20-minute break? How long should our break be? 20 minutes? Cigarette break? Yeah. We'll be back. All right, ladies and gentlemen. Here's what I'm going to say to you guys here. What comes next about this, the reason we said why we care about percent is language, right? Here's the language. You guys ready for some language? I'm going to ask you these kind of questions, right? What percent of the sample has question 1 at least one child? Okay, now go back and take a look at your table here, right? All of these questions are what? They're all percent questions. 62.5%, 20.8%, 8.3, and 8.3 percentages. So remember, it starts off, you need a frequency table, and then a relative frequency table, and it ends with the what? Percentage. So you might say, why do we do that? So we can answer questions that involve language. Remember, what's the hardest part? At least one. So let's ask you this question here when they ask you this kind of thing, right? Okay, what percent of the class has at least one child? You guys know what at least one means? That's right. At least one means one or what? Or more. Remember up here how I put the letter X here? X represents an arbitrary data value here, right? Just to kind of get you guys started from the first day in terms of some symbolic sort of, this is from algebra, at least one. If X is the number of children, just want to get you guys started on this. At least one says X is greater than or equal to 1. It's 1 or more. Remember I said language is the hardest part? So go back here. See the state of value 1? You see the state of value 2? The state of value 3? You're going to have to add the percentages that correspond to the phrase at least one in terms of number of children. So in other words, you take 20.8 plus 8.3 plus another what? 8.3. So you go, oh, okay. So let's go to the calculator. 20.8 plus 8.3 plus another 8.3. And what do you guys get? This is the hardest part, ladies and gentlemen. You're looking at the hardest part for some people. This will be what? 37.4%. So I'm going to write that down. And there you go. There's your answer. What do you guys think? Is that okay? Notice the phrase at least one. You have to know what that means. Okay? Let's ask you guys another question. How about this phrase? What does at least 2 children mean? That's right. 2 or more. That's all it means. You guys okay with that? 2 or what? Or more. So you guys want to take a look at that. At least 2 means 2 or more. So 2 or 3 in this context, right? So go back over here and you say, oh, do we have to add these percents? And the answer is yes. What happened there? Okay. So 8.3 plus 8.3, what is that going to give you? Now, can I do that without a calculator? Maybe, right? 16.6%. So there you go. This is the hardest part. Okay, so you're going to say what? Language is the hardest part, and then process. So I want you guys to compare and contrast. This is the whole reason why you actually gather data, organize data, so that you can start to answer questions regarding the data. How about this phrase? This is a phrase that I love. This is my most favorite phrase. No more than one child. No more than one. What does that mean to have no more than one child? Yes, it means one or what? It's one or less. Okay, so here we can say x is less than or equal to 1. At least 1 is x is greater than or equal to 1. No more than 1, x is less than or equal to 1. No more than 1. It's kind of like with my daughter. We drive by the mall, and what does she want to do? She wants to stop and what? Shop, buy something. Do you guys know what I mean? And she says, Daddy, and you know how your daughters are. They get away with everything, right? They sure do. Daddy, I want to buy an outfit. Like an outfit? No. Okay, I want to buy a pair of shoes. Okay, Ashley, you can have what? No more than one pair. You know what that means? She could have one or what? Or none. That's the best thing. Okay, you got to get used to that phrase, no more than one, because just because she doesn't find something she likes, does it mean she has to buy? No. You guys see what I'm saying? No more than one is one or less. So you're going to take 62.5 and 20.8. You're going to add those. 83 point what? 3%. And there it is, 83.3%. Okay, no more than one. That's another favorite phrase. How about this? How about we say more than one? We'll compare and contrast. What does more than one mean? It's what? You want to think of this as greater than what? One. You see these inequality symbols? These are the symbols we learn in algebra. Greater than 1 means 2 or 3. It does not mean to include 1. So more than 1, they're serious. They want 2 or 3. So go back to the list and say what? 2 or 3 here. Okay, so we're going to find 2 or 3. These are the outcomes that are more than 1. Oh, 8.3 plus 8.3, we know what that is. That's 16.6. Okay, so I want you guys to really focus on that, 16.6. What are you guys going to have for lunch later? You know McDonald's is across the street. You know how you want to order today? And they say, how many Big Macs would you like? Say, give me more than 1. Okay. Order less than 2. Less than 2. We're going to write that one down. Less than 2 milkshakes. What do you think they're going to say to you? Do you want 2? You say, no, I want what? Less than 2. What does less than 2 actually mean? Do you guys know? It means smaller than what? Than 2. See, I see this in terms of my inequality sign. Less than 2, right? You guys see these? See these symbols? See, you want to know these words. You want to know these phrases. More than 2, more than 1, no more than 1, at least 2, at least 1. You want to know these phrases. And smaller than 2 is 0 and 1. Smaller than 2 means you don't include 2. Okay? 0 and 1. So you're going to take the 62.5 and the 20.8 again. I think we've seen that one already, right? Wasn't that 83.3? Wasn't that like no more than 1? Okay. So sometimes these phrases can have the same exact answers. What do you think? Is that easy? How many filet of fishes are you going to order today? Am I the only one that likes a filet of fish? Probably. You guys don't like filet of fish? Really? Oh my God. Between 2 and, I'm going to say between 1 and 3. So I'll go later and say, I want some filet of fish. Well, how many do you like? Between 1 and 3. What does that mean, between 1 and 3? Well, you might think 2, and you're right in some sense. You are. But 1 less than or equal to X, less than or equal to 3. In other words, they want you to include. This is inclusive. They want to include the 1 and include the what? The 3. So between 1 and 3 means 1, 2, and 3. I know. Wouldn't it confuse those people there at McDonald's taking your order? Because it's not saying 1, it's not saying 3, it's saying 1, 2, and 3. Probably end up how? Yeah, I know. They get mad and they get it wrong all the time. I know. You know, one of the nice things about being old is it could be like an old man. You know, it's kind of funny to me. Sometimes I order and they have, you know, it's like they can't hear me. It's like, how come you can't hear me? You're talking into that machine. Can't hear you. You're like, what? You start thinking, oh, that's not my problem. It's thinking like, now I'm sounding like an old man. You guys know what I mean? That old crabby man. Not my problem. You can't hear me. They can't hear you sometimes. So I don't know. I always use this example of language because it makes people think. Makes them think like, hey, at least 1 order of fries? What does that even mean? It's like 1 or 2 or 3 or 4 or 5. At least 3. What does that even mean? 3 or 4 or 5, right? No more than 5 hamburgers. 5, 4, 3, 2, 1. Includes 0. Makes people think when you start using that language. And that's the thing about it. Like when people say, oh, the course is hard. This is probably for some people the hardest part, just the language. So the good news is you see it on the first day and then you'll see it over and over again. But if you get it right on the first day, then you'll get it right over and over again, right? But the real thing is to get this part of your vocabulary. Start thinking that way. How old do you have to be? Let's see. How old do you have to be to drink legally in California? Let's see if you guys know. How old? Be careful. You know what the most common answer is? 21. And I'll say, no, that means I can't drink since I'm forever 25. It'll be at least 21. 21 or what? Over. You guys know what I mean? What's the definition? This is in different disciplines, right? You guys' disciplines. What's the definition of a minor? Anyone that is what? Less than, you can say no more than 17. Or you can say less than 18. That's the same. Less than 18 means 17, 16, 15, 14, it's all the way down to 0. No more than 17 means 17 or less. How old do you have to be a major? Yeah, it is, believe it or not, in criminal code, meaning law, in criminal law, you have what's called technically a minor and a major. They're opposites. They're logical opposites. Yes, at least 18. 18 or older. So if you're 18 or older, you're considered a major. And your life is over because you're an adult. You guys know what I mean? Horrible. You're an adult now, 18 or over. It's the worst age group to be in. At least 18. It's horrible. I hate that. Okay, so those things are out there. So think about that. You know, to drink legally, you don't have to be 21. If you say you got to be 21, no, you got to be at least 21. So when I say start to think about this and get this in your vocabulary, it's because it's really there. You know, there's a group of ages here that apply. Like, does anybody know those child development majors? Do you have any of you in the room, child development? Okay. What's the definition of a toddler? I might have to look it up. Huh? Is it a toddler? I'm gonna look it up. Toddler. What? Come on. What? Oh, these weird questions. Okay, I guess I misspelled toddler. Oh, look how they define it. The CDC, 1 to 2 years old, between 1 and 2. You're a toddler if you're between 1 and 2. You say, what does that mean? 1, 2, just like this here. This is like the between language. So when I say to you guys, the definitions with this information are really everywhere. I think of it as you see it here mathematically. So if you said, what's a toddler, Mr. Judge? And you go, toddler? By the way, there's 2 D's in toddler. You got to be between. You got to be between 1 and 2. That's a toddler. I didn't know that. So I'm just remarking that what we show you here is really used everywhere, this language. And don't think it's just unique to statistics. It's really not. So what were we saying? Between 1 and 3, right? So these, we're going to have to take the what? 20.8. Let's get out. And 8.3 and 8.3. I wonder what a juvenile is. 37.4? Is there a juvenile 37.4? I'm going to look up juvenile. What is the definition? Oh, let's say juvenile definition. You're a juvenile. What's the age? A young person. I want to really find the definitions. Maybe that's not even a definition. It has to be. Juvenile definition, meaning. Doesn't even give it. All I'm getting is characteristic or suitable intended for a young person, young and youthful. Juvenile years, a young person. Well, that doesn't answer the question. There's a formal definition of juvenile. I wonder where it is. I might have to dig. Young person. That's too vague. Anyway, whatever. This is the kind of questions that you're going to be seeing. Okay, should we have you guys start from the beginning? Put it all together? Because it's one thing to go through it with me. It's quite another to do it your what? Self. Now I'm going to share with you guys here again. If I go to the browser, here is my website. Now, if you go here, what is this titled? The New Elementary Statistics Library. There's an old one. I actually created a bunch of videos, ladies and gentlemen, for this course. I have a lot of resources. This first one you see is called Probability Review, and we'll talk about that a little bit later. And then the next one, or as you scroll down, you got statistics lecture 1. So notice, I've been doing this kind of multimedia stuff for a very long time. I recorded this lecture. Notice, how many children do you have? This is back when 720p was the standard of the day. That's a long time ago. That's Mr. Judge. I think I'm going to shave tomorrow. What do you guys think? No? I want to go back to that shaven Mr. Judge. How many people vote for shaved? Just curious. How many people vote for non-shaved? It's an interesting thing. It's interesting. Anybody here vote for shave? Only one? Well, here's a shaved Mr. Judge. 720p. This is going to be part of your homework, by the way. You'll see. I'll talk about that later. You see this first worksheet? What do you think that's saying there? How many cups of coffee do you have per day? You guys see that? So, like on your homework, what did I do? If I can figure this out, can I get rid of this portion here, this left side? How do you, oh, that's all you do. Jeez, that's all I had to do. Okay, you guys see that there? How many cups of coffee do you drink per day? And notice I gave you guys some data. Is that true? This is like your homework, ladies and gentlemen. And then what does it say? Organize your data into a frequency table and a relative frequency table. So on the left, you got frequency table. On the right, it's a relative frequency table. Okay? And then I even tell you, approximate the relative frequency to the nearest what? Thousandths. Just like we just did. And then what do you guys see here? Questions. Like we just did. So you're gathering data, you're organizing data, and yes, you got to convert it to percents. And then you got the language portion. Isn't that what we just talked about? So you give you guys some time to create these tables, and then we could go through the language. Can you guys see that? Let me make it bigger if you can't see it. How do I make it bigger? What's that? It's on my website, and I'll put the link. I'll show you. I'll put a link. What I'll be doing is I'll share with you at the end. I'm going to put a link here to this worksheet. I'm going to put the links there, and it's going to be in Canvas. It's going to be in the assignment portion. The assignment portion titled, what do you think we're going to title it? Let me share with you guys what I'm going to do. See that assignment portion? Yeah, I'm going to do this. You go, wow, there's no homework. I don't like to scare people. Here's the name, homework 1. That's not true. I'm just making that up. And you say, what's the date? When is your first test? What time does class start? See that here? So what I'll do every day for you guys, share in the browser, everybody can see it. And that's AM. So what I'll do every day is I'll add to this thing called homework 1. It's going to be in Canvas. And then you say, well, what's in it? Well, I'll print stuff. I'm going to do it here. It's the... And I'm going to put a hyperlink for that. And then I'm going to call this statistics lecture 1. And I'll put hyperlinks. I'm going to do the hyperlinks for it. So like for this one, for example, because I want you guys to see and get used to it, and you go, oh, I know what's kind of there. I think I have to go back to, where are we at? Oh, yeah, there we are. See this? So this is what I kind of do. But I want you to go through this one here. I'm going to put the hyperlink. And I'll do the probability review as well, but I'm going to save and publish. So now you say, what's there? Your homework 1 is there. You just click on the link. But I'll put a hyperlink for the whole resource in case you guys miss it. That resource page. What's it called? It's called the what? The new elementary statistics library here. You see this thing here? I'll give you guys some background. All of this was done pre-Khan Academy. See, I was doing this, well, I should take that back, at the same time. Way back in 2007, 2008. Here's what I mean. Let's say you're working on this and you get frustrated and you get stuck. You know what you can do? What is this down here? That's your favorite tutor.
Okay, this is the home.
Who do you think that is? It's me. So if you get stuck, what am I there going to do? I'm going to help you out with how to do this. If you get stuck, I did all the odds. So I'm your tutor. So here's the idea. You had lecture. There you go. You had the worksheet on the lecture. And then you have the video tutor in case you got stuck. What do you guys think? Is that pretty good? So this is all it's at the same time. And why I call that the new library, you say, why do you call it the new library? Because back when I wrote this stuff and I did this was you guys are probably born in 2007. You say, I was born in 2007, Mr. Judge. I did this back in 2007 when you guys were born. You said, well, where is it? Well, the school, I had my own streaming server at that time. Such a big shot. Had my own server on campus. Oh, my God, such an amazing thing. And then what happened next was, they told me, can you move it on YouTube? Because it's, what is it? Or they had a bandwidth issue for campus. So they want it on YouTube now. So that's when I moved it on and called it the new. I kept the old one up for nostalgic purposes. This is the old. It's in the old days. So you go to the new one. And, this is probability review. I'll get more back to that one. But I'm going to put the links there. So I'm going to be putting the links for you. You guys could take a look at that. It's on my website. And that was done at the same time as Khan Academy was done. The only difference between me and them is they're millionaires and I'm not. Sad to say. Very sad to say. Isn't that horrible? Huh? Do I? Oh, wow, that's kind of funny because, we're doing the same thing. But mine I have a lot more resources than they do, like a lot more depth. Anyway, we'll call that Statistics Library. So when the pandemic hit, I was all ready. People were like, yeah, but I'd never taught courses online. This is all for the in-class students. So this is what we call that Video Statistics Library. And I have it for other courses too, by the way. So anyway, what I wanted to do, I wanted to show you guys that. What I wanted to do here, though, is have you what? Practice this. I'm going to give you guys some time to do what? Can you guys see it? Organize your data into what? Where's the clock? Both frequency and relative frequency approximated to nearest thousands. Okay, let's see what you guys get here. All right, let's take a look here. If we can. Let's see. What can we do? I think, let me double check here something here, okay? It's Statistics Lecture 1. Let me see. Okay. See how I have to organize my data? I have to find the frequency of the data value 0. Is that true? Okay, so let's do that. How many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any others? No. So what's my frequency? 10. Good. Okay. I think I'll just put it in blue. Outstanding. Good. Wrong button. Okay. Now, what's the frequency of the data value 1? 1, 2, 3, 4, 5. Okay, so that frequency is 5. Is that right? All right, good. What about frequency of the data value 2? You say 6. Let's try this out. 1, 2, 3, 4, 5, 6. Looks like you guys are correct. Okay, good for you. 6. Okay, frequency of the data value number 3. What'd you guys get? 5? See, 1, 2, 3, 4, 5. Uh-oh, what happened? That's odd. Okay, let's try to get the iPad back. I'll leave you with the calculator for now. Say, come back, iPad. Hold on. No, not that guy. How's my hair? My hair, huh? Let me get something. It's weird. Come back, iPad. I didn't even hear it. I didn't even hear it say anything. Usually it makes a sound. I'm going to reboot this.
To do that, you'll
I don't want Siri. Jeez. Oh, this insanity. See if that does the trick. There, I did hear something. All right. Okay, now. There we go. We are back. Sorry about that. I don't even know what that means. Okay, we are, what number was that? That was gold, right? Or brown? Okay, so what was the frequency? Now that leaves the last one, which is 4. We got to find the color. Maybe orange. Okay. 1, 2, 3, 4, 5. Uh-oh. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8. Did you guys get 8? Okay. Now, this is our frequency values, okay? So if we're going to get relative frequency, we need to add these numbers. Is that right? So we're going to have to add. We're going to get the sample size here. So the sample size is found by adding all these numbers. So 10 and 5 is 15, plus 6 is 21, plus 5 is 26. What's 26 plus 8? 34? Okay, so relative frequency now, right? So you say, what's the relative frequency? Well, it's 10 out of 34. 5 out of 34. 6 out of 34. 5 out of 34. 8 out of 34. But they want us to approximate this to the nearest, what? 1,000. So we're going to have to go and put all of these fractions in the calculator to the nearest thousands. How many decimal places are thousands? 3? Okay. So, okay, let's find the TI. $10 divided by 34. So what are you guys going to get? It's going to be 0.294. What's the digit to the right of the 4? It's a 1, so it's 0.294. Okay, good. All right, now, oops. 5 divided by 34. What do you guys get here? 0.147. Okay, pretty good. Now, 6 out of 34. So the nearest thousands, you get point what? 0.176. Okay, now 5 out of 34, I think I have some deja vu. So 0.147, I don't have to do that again. Now 8 out of 34 should be 23.5. Or point. Yeah, 0.235, I guess. So ladies and gentlemen, take a look. These are all of what we call relative frequency values. They're all decimals, okay? Now, when you move it 2 spaces to the right, what do they become? These are going to be percent. So this would be 29.4%, right? Or multiplied by 100. Every decimal can be written that way. 14 point what? 7. 17.6%. 14.7. And then what? 23.5%. These are all percentages. Okay, now you say, why would I need to do this? Remember, we could let the letter X represent an arbitrary data value. They're X values. Because when you go and look at the language, what does the language say? Right? It says, what's the first question? What percent drink at least 1 cup. So X is the number of coffee drink per day. What is at least 1? It's 1 or more. So we write that X is greater than or equal to 1. This means 1 or what? Or more. So 1 or more, you're going to have to go back here. 1 or 2 or 3 or 4. We're going to add all of these here. Is that true? Okay, you guys see what I'm saying? That's what we're going to add. This is what's there. So, all right, let's get out the calculator. 14.7 plus 17.6 plus 14.7 plus 23.5. And what do you guys end up with? That's 70.5%. Okay. So the answer to that first question here is 70.5%. 70.5% of the sample, right, has what? Drinks at least 1 cup of coffee per day. Okay, so you're going to put together the process and the language. What about more than 1? How do you represent more than 1? X, strictly greater than 1. So compare and what? Contrast. What's more than 1? You guys know it's 2 or more. Is that right? Okay, 2 or more. So you're going to go back over here, but this time you're only going to add, you're not going to use the 14.7. You're going to add all of these. So that's 2 or 3 or 4. 17.6 plus 14.7 plus 23.5. So here we go. And what does that give you? It's 55.8%. So ladies and gentlemen, 55.8% of the sample drinks more than 1 cup of coffee. That's answering question number 2 here. Okay. What does question 3 say? What percent drink less than 3? So strictly, what does less than 3 means? 2 or what? Yep, 0 to 2 or 2 or less. Okay, 2 or less. Less than, what do they say? Oh, less than 3 means 0, 1, and 2. So we're going to add those percents. 29.4, 14.7, 17.6. Okay, so you get what? 9.4 plus 14.7, 17.6. 61.7%. Is that right? Okay, there you guys go. What do you guys think? Is that one okay? What does no more than 2? No more than 2. Remember my favorite phrase. I like no more than 1, but no more than 2. 2 or 1 or 0. It means 2 or less. No more than 2. It means 2 is the limit. And you might say, I have deja vu. Yeah. So I'm going to copy and I'm going to paste that thing. Okay? Sometimes these phrases are the same, have the same meaning. What about between 1 and 3? You guys remember how we represented that one earlier? It's 1, 2, and 3. So X is the number of coffees. That's going to be between 1, 2, and 3. $14.7, 17.6, another 14.7. And you end up with what? What is this? It's 47%. Okay, now this is what I have here for you guys to work with. These kind of questions, gathering data there. You don't have to really gather the data. It was gathered for you. It's listed there. But you got to organize it and using the definitions, and then you got to answer those questions with language here. Those are the kind of things. Now, it gets better, sort of. Let me ask you guys another question. Let's see if you guys can appreciate the difference here. See what I'm talking about here. If I go back now to the iPad. Okay. I'm going to ask you guys another question. Here's another bad exercise in gathering data. Ooh, you guys are going to, if you like that other question, you're going to like this question even better. Okay. Ooh, even better. How old are you? No, Mr. Judge, you don't ask that question. How old are you? Should we do a convenience sample? 38. Good. Okay. The two ladies in this corner here. 18, okay. Did we get you? The lady with the green. How old are you? 21. Okay. How old? 28. Okay. Let's see the gentleman. The lady. Gentleman.
29.
Did you, 18? Okay, maybe just a few more here. And then the gentleman here with the hoodie. How 20? Okay, good for you. Thank you so much. Okay, now I gathered data again. You can represent this with the letter X. Remember this? This represents arbitrary data values. Okay, so we represent that with the letter X. Now we're asking, how old are you? Now, once you gather data, you may notice something about this, though. There's an issue here. There's a problem. What are you supposed to do? If we try to organize our data, right? Say X is your age. I can put an age column here, or I can put the letter X. I'll put both. Let's find the frequency. You remember what we did before? What did we do before? We started with the smallest, right? So we go 18, 19, 20, 21, 22, 23, 24. Where do we stop? At 39? Now, what's the problem with that? Well, there's a lot of columns, or I should say there's a lot of rows, right? Now, you know what the oldest student I ever had was? I think he was 84. So when I went through this data exercise, I had a 16-year-old in the class, and I had an 84-year-old in the class. So we started at 16, we had to go all the way to 84. Now, there's an issue here. What is the issue? There's going to be a lot of zeros in between. I'm going to say to you guys something here. We're going to have to do something. We're going to have to fix this situation. You see, we have a definition. You guys want to write down the definition. We have what's called the range. And that's the largest data value minus the smallest. So the reason I give you this definition is because the range of data is kind of large. You might say, what do you mean by that? Well, 39 minus 18. Okay. So my range, 39 minus 18, what's this range going to be? Because sometimes they ask you for the range of your data. Yeah, the range is 21. Compared to the last range, what's the range of the last example? Or I should say, not the last example, but the range of the example where what? Yeah, when we ask you how many children you have, that's actually not 4, it's 3. So when you have a small range, here's the point. 3 minus 0 is 3. When your range is small, you can get away with listing it this way because you're not really looking at, in some sense, a lot of rows. It's only looking at 4 rows. And your eyes or your brain, whatever it is, only likes to look at a small amount of rows. Now, you might say, okay, well, how do I fix this situation? Since our brain only likes to look at a small amount of rows, we can actually fix this. You say, what's the fix? The fix is known as grouping your data. Okay? So I'm going to group the data. And I'm going to group the data into what we call bins. You guys know what a bin is? We think of bins as like a container. Like you have a trash bin. What is it? What is that? It's a container that holds trash. We have a recycle bin. What is that? It's a container that holds recyclable items. So think of it as just a device that holds. But we're going to hold data values. So here's what I'm going to do. I'm going to say, okay, what was my range? Okay. 18 to, this would be 23, 28, 33, 38. So we'll say 18 to 22, 23 to 27, 28 to 32, 33 to 37, and then this will be to 42. Okay, and this is going to be called the first what? The first bin. I might have to just move this because I want to put the phrase here, okay? So what does the first bin hold? Do you guys know? The people that are the age 18 to what? 22. We're grouping our data. The second bin is going to hold people that are between 23 and 27. The third bin holds 28 to 32. The fourth bin holds 33 to 37. And then the fifth bin holds 38 to 42. So these are bins, ladies and gentlemen. They hold data values. Now, the most common question people ask is, they say, Mr. Judge, how did you actually figure out these bins? Well, I'll tell you later. I'll tell you later how I made these bins. So don't worry about it for now. Okay? Just focus on the process here because that's going to be important, right? First bin, second bin, third bin, fourth bin, and fifth bin. So we're going to put data values in bins because we want to organize our data how? In terms of what? A frequency table. Okay, this is an issue. A large range means we have to organize data in bins. Now, let me ask you this question here because you got another problem here, okay? I'm going to create something called a tally. Do you guys know what a tallies are? You ever play kickball in elementary school? Okay, maybe you say I didn't play kickball. Yeah, tally mark. How does a tally mark go? 4 lines, and then on the fifth one, it's a dash. Do you guys remember doing that kind of stuff? Okay, good. We're going to do tally. You want to do a tally. Because if I said to you, how many data values are in the first bin? You're not going to know how to do it. You can't do it. It's not like the last example where you just counted. So we're going to do a tally. We have to do an intermediate step, creating this tally. So this is how this works, right? So if I said to you, you guys know, what bin does the data value 38 live in? Put a tally mark. Yeah, put a tally. You're going to find the frequency this way. What bin does a 19-year-old live? First bin. 39. Good. 19. Good. 18. 18. First. What if you're 21? That's a diagonal. That represents 5 data values so far. Okay, do you guys see what I'm saying? So when you get to the 5th, you do a diagonal. Now, 21, where does that live? First bin. 28, where does that live? Third bin. Good. Where does a 23-year-old live? Second. 19. First. 19. First. 29. Third. Good. 18. First. 25. Second. 18. First. That's 4. It's now another. It's a diagonal. That means 10 so far. You guys okay with that? Where does an 18-year-old live? Okay. Now 19. And 20. Okay. What are you guys really looking at in terms of the tally marks? Okay? When you're counting and you're putting your data in bins, what are you guys really looking at? That's a frequency. Yeah, that's your frequency. You guys see that? Does that make sense? But it's the frequency now of the first bin, the frequency of the second bin, of the third bin, of the fourth, and the fifth. So what does 5, 5, and 3 represent? 13. So ladies and gentlemen, the frequency of the first bin is 13. We're finding frequency of bins, not data values. Okay, frequency of the second bin. What's that? And then a 2, and then a what? 2. Oh, how boring. Should we make up data again? All right, whatever. Okay. What's this called? What are you guys looking at? What do you think this is called? A frequency table. Yes. It's a table of frequency values. Okay. Also, let me ask you guys this question. What's the sample size? What's N? Well, let's see. What do we do? Don't we add the frequencies? Remember that one? Sample size. So N will be 13, 14, 15, 16, 17, 18. We got 19 data values. Good job. Easy breezy, lemon squeezy. Add your frequencies. It always gives you the sample size. This is why I even put the formula there. Now, if they ask you to get a relative frequency, again, to the nearest thousandths, you'd have to do what? What's the definition? 13 over 19. 2 over 19. 2 over 19. 0 over 19. And then 2 over 19. This is going to be kind of simple because it's only going to be about 2 calculations here. You guys see what I mean? Okay. So let's go out to the thousandths again. And I'm going to have to go to the TI again. Say, okay, TI, let's clear you out. So 13 divided by 19, what does that give you? What's this? 0. What? 684. Good. Now, 2 divided by 19. What's this going to give you? Okay, and then what's 2 over 19 again? Okay, so let me go back in the iPad Pro there so you guys can see that there. And what are you guys looking at? Those are all the relative frequencies of your what? Of your bins. And what's inside the bins are data values. A bin is a container. You had to group the data. Okay, so now we can go about this. If I said to you, I know there's 5 bins. I'm going to move this all over. What do you think what kind of column am I going to create now? Percent? Why would I create a percent column? Because they like to ask you questions on your data. Right, so this is a 68.4%, right? Move the decimal 2 spaces. 10.5%, 0%. Oops. It's another 10.5. Percent, and these are all the percentages, so you guys know. Okay? Easy breezy, lemon squeezy. Remember, there's going to be questions where you have to organize your table, your data in bins. I'll express to you guys how to do that. I just want to go through the exercise of gathering and organizing the data with you first, because I like asking questions. You say, what are the questions? What percent of the class here? Remember, what does this data represent? Your age? Yep. What percent of the class is question 1? At the very least, you're at least 23 years. Question 2. At least 33 years. Question number 3. You're less than, they could use a phrase less than or younger than. You're less than 28. Question 4. You are more than You're more than 22 years. Question 5. No more than. I love that phrase. I don't know why. No more than. You're no more than 32. And of course, last but not least, we'll say you're between. You'll be between, ladies and gentlemen, 23 and 37. So these are the kind of questions we want to ask of you. I'll give you guys some time to try this out as well. Okay? Because it's going to get you to think about all these phrases again. So I'll give you guys a little bit of time. Let's get out the clock. And let's see what you guys get. Okay, ladies and gentlemen, let's see what we can do with this. All right, let's see what you guys. What does at least 23 mean? Do you guys know? Remember, X represents the age. So at least 23, what does that mean? Well, isn't that, you know what it's short for? At the very least 23. So it's 23 or what? Or more. Okay? 23 or more. How old do you have to be to drink legally in California? At least 23. You say no, because that means 23 or more. Is that right? You guys okay with that? You guys with me on this one? 23 or more? So which bins hold data that's 23 or more? 2, 3, 4, and what? 5. So 10.5 plus 10.5 plus 0 plus what? 10.5. You can do all that in the TI. So we say 10.5, really times 3, is that right? 31.5%. So, ladies and gentlemen, not too bad. 31.5% of the class is at the least 23 years of age. Okay? 23.5% of the class. What do you think? Easy breezy, lemon squeezy? What is at least 33? So now I'm going to say, what about at the very least you're what? 33. What does that mean? Yes, it means 33. That means X is greater than or equal to 33. 33 or what? Or more. So we have to find the bins that hold data values that are 33 or more. So, looks like it's the last two bins. Is that true? So you're going to add 0% plus 10.5%. What's 0 plus anything? Itself, 10.5%. So ladies and gentlemen, isn't that true? At least 33 is 33 to 37 and 38 to 42. This is how we organize our bins now. So that answer is 10.5%. Easy breezy, lemon squeezy. First one's 31.5 because at least 23 means 23 or more. Think of it as saying you're at the very least 23. How about less than 28? Anybody in the room here less than 28? What does less than 28 actually mean? Less than 28 means you're under what? 28. You have to be smaller than 28. So, yeah, what bins hold data values smaller than 28? You say, isn't the 28 right here? It is. But it has to be what? Less than, smaller. So that's 23 to 27, 18 to 22. It is these right in here, ladies and gentlemen. So we have to add 68.4 with 10.5. I could do this in my head. Isn't that 78.9? Don't need the calculator for everything. Is that right? 78.9%. If you want to use the calculator then, but use the calculator, that's fine. Remember, what's the hardest part of this class? It's not the arithmetic. It's not the math. You get a calculator for that. It's language and what? Process. Okay, less than 28, we can say smaller than 28. X. This is why I like the inequality symbols. You know, less than 28, that's literally less than 28, age less than 28. More than, well, this is literally, more than is the greater than. You're more than 22 years. You are greater than 22. That's the word more than. So you guys know that. More than 22. More than 22. So you say, I see 22. It's right in here. But what's more than that? All the other bins, 23 to 27, 28 to 32, 33 to 37, 38 to 42. It's all the other bins. That's right. And let me be careful here. It's bins 2, 3, 4, and 5. Oh, that's the 10.5 plus 10.5 plus 0 plus 10.5 again. That's a 31.5%. We did that. That's the first one. So sometimes those things come up again. The key is language. Language. Okay, no more than 32. Remember, that's my favorite phrase. What is no more than 32? X is less than or equal to 32. It's 32 or what? Or less. It could be 32 or it could be less. Imagine if you said, I want no more than 32 chicken nuggets today. They're not going to think that's funny. No more than 32 chicken nuggets. Anybody here like chicken nuggets? How could you not like chicken nuggets? What's in the chicken nuggets? I don't know. I have no idea. I don't know. I wish I knew. What's in the French fries? Is it really potato? Sometimes you don't know. I don't know. What's in the fillet of fish? Yes. Is it fish even? My God. You guys don't like that stuff? I do. You know what I ordered at my favorite restaurant? Fish and chips. It actually is pretty good. It's one of their specialties and one of my favorite places. What's the place? Oh, good fish and chips? You're going to have to get out of this LA County, though. You have to go to the OC. There's this place I go to called Taps Fish Brewery in Brea. Yeah. Oh, yeah. That's my place. I've been there. I've been going there for years. It's my place. Go to Taps and you order the fish and Taps in Brea. There's two things you order in Taps, okay? Well, yeah, the beer, you get the Irish Red, which is a really number 2 popular beer, but I like Irish Red. I think it's the American Cream is number 1. So first of all, you have to order the beer because it's a brewery. But the number 1 and number 2 dish, of course, it's a fish place. Fish and chips, award-winning fish and chips. Very good. You'll like it. If you like fish and chips, you go there, you go, pretty good fish and chips. The other one is the Chilean sea bass. If you guys don't know about Chilean sea bass, it's like the filet mignon of fish. It's not just any sea bass. It has to be what? Chilean sea bass. It's pretty good there. That's all. That's all I get there. Anyway, why am I thinking of fish and chips? I know it's hungry. I'm getting hungry. Only had cookies for breakfast and lunch. No more than 32, 32 or less. So you might say, here is my 32. And 32 or less are all of these bins. You guys okay with that? You guys see that what I'm saying? It's the first 3 bins. So let's find this here. 68.5 and a couple of 10.5s. Is that right? Or 68.4. I apologize. So 68.4, add it with a couple of 10.5s. 89.4%. Okay, no more than 32, 32 or less, 89.5%. Now, between 23 and 37, and I just want to let you guys know, they're going to be very strategic with how they ask you these kind of questions. Because I can't ask you between 22 and, like 30. If you guys notice, they have to be strategic. So this is really bin 2, bin 3, bin 4. So you're going to add bin 2, bin 3, bin 4. That's between 23 and 37 because it's inclusive. Include 23, include 37. 10.5, 10.5, and 0. What does that give you? 21%. Good. I'm not going to use the calculator for that. $23 less than to X, less than or equal to 37. This is the between. I'm going to give you the math representation for all of these as well, so you guys could go home and study that, and you can start becoming a little bit more efficient with how that is so you can remember it, because that's how we're going to be using this notation later on in the course. So I always get students started in the first day with it, the notation. Okay, but that's kind of why you take some of the prerequisites of intermediate algebra. You learn about the linear inequalities, all those things. And then when people say to me, Mr. Judge, I got to give you some more definitions, you might say to me, how did you know how to organize the bins? Let me give you a couple more definitions before I show you guys how to do that, okay? But let me ask you this first question. I know this is going to probably start a fight in the room because people are passionate. Where are the best tacos? See what I mean? You're like, oh. It's already. Where are the best tacos locally in LA here? I'll tell you guys where. No, not Taco Bell. Don't go to Taco Bell. They're not bad there. They're okay. Taco Bell's okay. You guys know what I'm saying? They're all right. They're okay. But where are the best tacos in LA? I know some of you guys are going to be like, oh. Some people say, I think maybe King Taco. No, I know. King Taco's not bad, but if you've had good tacos, then you know the difference. You're like, wait a minute. King Taco's been messing with me all this time. Because I used to think King Taco was pretty good. It was. Not bad, but then I had these other tacos, and I said, wait a minute. I can tell now King Taco is, that meat's frozen. It's frozen. If you guys didn't know, they reheat it. It's like processed already and frozen. King Taco. Did you guys know that? You could taste it. All right. Did anybody know where Pep Boys used to be on Atlantic? I'm talking used to be. Because all they have is a tire place. If you ever go there, anybody ever been there? Yeah, I go there. Do you like them? Pretty good tacos? Oh, you know where it is. It's in the parking lot. Yeah. Those street tacos, those guys that are always there, there's a reason they're always there. You're like, man, these guys are pretty good. They're good. Tried them once. They're pretty good. And then I said, I'm going to go again. They're very good. Yes. Okay. Very good tacos there. Street tacos. You order them. You very good. But don't go late. Don't go like really late, because by then they're kind of tired and who knows what's there after a while. You know what I mean? They're kind of, you get the leftovers. But if you go there at a reasonable time, don't like, not at the end, like 11:30 or whatever, 11. Really good. Very good tacos. Unbelievable. I'm like, man, so good you crave them. You might be watching TV or Netflix at night. Like, man, I could go for some of those tacos. It's like, I just ate dinner 3 hours ago, and I'm craving those tacos. I tell my wife, I'll be back. I'm going to go get those tacos. I'm not sure, but I went there, because I've gone there, like, I go there. But then we went the other day, maybe a week or so ago, or two, maybe 10 days ago, a week or 10 days ago, at kind of late, like at 10. And it was like, it wasn't, you're like, wait a minute. These guys were tired. The Apple store didn't have any pineapple left. You know what I mean? No more limes. You're like, what? At the bottom of the barrel there, and you're like, man, I don't know. This wasn't as good, so I know don't go late. I don't know if it's like at 10. I might have been there about 10. Go earlier, like 8. Yeah, how much are they? They're like they're expensive. $2.50 maybe. That's kind of expensive. That can be. If you eat 6 or 8 of them, I eat 6 or 8. They're small. You guys probably eat more. They're small. They're like, you get 3 asada, 3 al pastor. That's how I started. Now I'm at 4 asada, 4 al pastor, sometimes 3. They're small, but they're kind of expensive, I think. I think they're like $2.50 or something. Best place ever. I'm telling you. Now you know what fresh is. And if you compare that to King Taco, you're like, oh my God, I'll never go back again. I told my wife, I'm never going back to King Taco. I hope those guys stick around a while. Nobody's been there? Jeez. You've been there?
Yeah, but I prefer another taco spot.
Do you really?
It's on Whittier Boulevard behind the Numero Uno market.
Uh-huh.
Local TJ style tacos. Those are bomb.
Where is it?
On Whittier Boulevard.
Whittier Boulevard? Behind what?
The Numero Uno supermarket.
Behind the supermarket? What's it called?
Numero Uno. Yeah,
That's the supermarket.
it's behind there. It's in the parking lot.
And the tacos? Oh, I see what you're saying. They're not really called numero uno, are they?
No, the tacos are called tacos on Cuco. They're only there on weekends.
Yeah, these guys are there. I don't think they're there right now. They might be there starting at 4 or 5. They're even there on the weekdays, I think. Yeah. So they're on the weekdays. Some of those places are like unbelievable. I used to watch all the time and they're like, I got all these people there. Now I'm like, okay, I'll stop, try it out. Like, whoa. Better than I ever thought they'd ever be. Anybody know what I'm talking about? You know what I'm talking about. Is it fresh? Yeah. Exactly. I know I'm hungry. It's lunchtime. Oh, I got to give you a couple of definitions so you guys can figure out how to do this. It's kind of simple, okay? Let me give you a definition, 2 definitions here, and then I can think of lunch or dinner. Definition of, what do we call this? Oh, I got to tell you guys that one. No, definition of the bin. Oh, I got to give you. Okay. God, I got to give you so much definitions. Lower bin limit. Okay. And definition of the upper bin limit. Okay, I abbreviated LBL and UBL. So it's a very, very simple definition, these two. This is going to be the smallest data value a bin holds. This is going to be the largest data value a bin holds. Okay. So remember, a bin is like a container that holds data values. Lower is the smallest data value. Upper is the largest data value. Okay. So we got a bunch of definitions here just to kind of think of this thing. So what I'll do is I'll copy this. If I can get this out here. And I'll clean it up here because this is an important detail. These Largest data value, smallest data value. Very simple. UBL, LBL. So remember, what's a bin? Like the first bin, it holds data values between 18 and 22. Is that true? So let me share with you guys this. These are, see this in orange? Those are all my lower bin limits. Those are all the smallest data values a bin holds. So for the first bin, the smallest data value is what? 18. You guys okay with that? What's the largest data value? 22. That's in green, so this will be 22. See what I'm saying? For every bin, it has a smaller data value and a larger data value. So what's the smallest data value for bin 2? 20. What's the largest? 27. Smallest data value for bin 3? 28. What's the largest? Smallest for the fourth bin. And then 37. And then 38. And then what? 42. So I just want to share with you guys, this is a very simple definition. Turns out it's necessary for discussion. Okay. Now I'm going to give you this other definition here. Definition of the bin width. Bin width. And that's defined to be the difference between adjacent what? Bins. I'm sorry. Difference between adjacent lower bin limits or upper bin limits. Now, you guys know what the word adjacent means. In math, adjacent means what? That word? Next to. It means like right next to. Because being next to is vague. It can be. Being right, they say, what do you mean? How next to? Right next to. Like next door neighbors. That's adjacent. Next to. So if I said to you, oh, okay, you see this? You see these two adjacent lower bin limits, 18 and 23? What's the difference between them? Subtract. Subtract that. What would you get? I'm going to say bin width is what you do. Take 23 minus 18. What's that going to be? 5. Yep. Difference is 5. And if you said, well, what if, do I have to take the first two? What if I want to take the last two? What's the difference between 33 and 38? 5. Do you see what I'm saying? What if you said I want to do adjacent upper bin limits like 27 and 32? What's that difference? Subtract 5. Oh, the difference between 32 and 37. What's that? 5. 27 and 22. What's that? 5. Okay, you guys okay with that? So the bin width is 5. Let me think about this. What else? I think we're there. I think we know how to do this now. I think we know how to create what we call these. I think we know how to organize. I think we have the definitions to organize our data in bins. Okay? So let me share with you guys that. Let's look at an example here. I'm going to go to my own worksheet and share with you guys, like starting on number after 6, starting at number 7. Okay? I'll share with you guys how to start to organize your data into bins. They tell you what to do. This is all the data. We got to organize it. But what do they say? Notice this. Construct a frequency table using a what? Bin width of 2. Okay. And the first bin having a lower bin limit of 4. So your first bin has a lower bin limit of 4 and the bin width is 2. They're telling you how to organize your data here. So you might say, what does that mean? Well, first bin, lower bin limit. Remember this? Say the first bin. What was that lower bin limit? It'll be 4 to something. Then you'll have a second bin, okay, and a third bin and so on. You guys see my point? What's the bin width? 2. So you know what you do? You take that 4 and you add 2 and you get the very next what? Lower bin limit. These are LBLs. Add 2 and you get what? 8. Add 2 and you get what? 10. And then 12. And then 14. And then 16. You go, but where do I stop? Well, yeah, if you don't have any data that goes in a bin. However, these are all the what? Lower bin limits. How do you get the upper bin limits? Well, if this is from 4 to 6 for the first bin, what's the upper bin limit have to be? Yeah, what's one less? 5? And then keep adding the bin width of 2. This is 7, 9, 11, 13, 15, and 17. So these are all my upper bin limits. You're just organizing some data. So this is how we begin to organize data. Now, remember, you say, well, how many bins do I need? Go back. What's the largest data value? I see 12. Does anybody see a larger data value? I think the largest data value is a 12. What do you guys think? And in fact, I see about 3 of them. I see 3 12s. There might be 4. Oh, let's see. You're right. I see 4. You're right. There are 4 12s. So what do you think we'll do then? We don't have a need for this bin. We don't have a need for this bin. The largest data value is a 12. So this is how you start to organize your data, ladies and gentlemen, in terms of the bins that we did earlier. What do you guys think? Is that easy? Okay, now I'm going to change this on you. This is when the bin width was what? 2. What if your bin width was 3? Remember, you're going to start with the 4. And so use the bin width value. What's 3 plus 4? And then what? 10, and then what? But remember, it only goes up to 12. So you're pretty much done already. Does that kind of make some sense? Okay, what's one prior to 7? Before to 6. Now use the bin width. 9, 12. So ladies and gentlemen, this is going to only have 3 bins if the bin width was 3. But that's how you start to organize data in terms of bins. They're going to give you the first bin lower value. They're going to always give you what? Where to start. And then they're going to give you the bin width. Okay? So you say, I don't believe you. Let's look at the next one. Construct a frequency table using the bin width now. What's the bin width of what? What's your bin width? 3. First bin having a lower bin limit of 4. So there's where you start. You start at 4. What's the bin width? That's 7, 10, 13, 16, forever. What's one prior to 7? That'll be a 6. Okay, you guys okay with that? Now keep adding the bin width of 3, so that's 9. 6, what? 9, 12, 15, 18. But you say, Mr. Judge, how many bins do I really have? Look at the largest value. 13's the largest here. Is that true? No. Is that? Oh, yeah, you're right. 13. I thought I seen a 15. So that means the last bin is not needed. Largest is going to be what? 13. Okay, you guys okay with that? Now, all right, let's take a look. I'm going to take a look at a couple of things here. Let's see what our time is really like. What's the deal here? Statistics lecture 1. Probability review. Oh, yeah. Okay. So here's the thing. You got this. You see this worksheet, probability review? See if you can see this here. Probability review, I typically have you guys, what do I have you guys do? I have people watch this probability review. It's like 18 minutes long. It's at 360p. Man, is that in the old days or what?
The mathematics of probability.
Something's wrong.
The 20